A high-speed train is going to cross one of the busiest sea straits in Asia by diving more than 100 meters straight down into the earth, tunneling beneath the seabed itself, and coming back up on the other side without ever slowing from 350 kilometers an hour. That is real. It exists. It's already under construction, and the boring machine doing the digging has already set a world record doing it. Before this list is over, you're going to see a bridge and tunnel system that used enough steel to build 60 Eiffel Towers, a rail crossing being carved out from underneath the Yangtze River itself, and a planned tunnel so long that it would outmeasure the two most famous underwater tunnels on the planet combined. Every figure in this video comes from verified government engineering reports, state broadcaster coverage of the actual construction sites, and international engineering trade press, cross-checking depths, lengths, and dates across projects that are still actively under construction took real digging. So if that effort is useful to you, hitting like and subscribe genuinely helps this channel keep doing it properly. By the time we reach the top of this list, you'll understand why American infrastructure engineers have started using Chinese tunnel projects as the new benchmark in their own planning documents. Let's start with the tunnel that already holds a world record most people have never heard of. Number 6 on our list is the Jinan-Huanggang Road Yellow River Crossing Tunnel, and it earns the bottom spot here because it already holds an actual world record, even though most people outside the engineering world have never heard its name. Here's the backstory. Jinan is the capital of Shandong Province, split by the Yellow River. China's second longest river, and one of its most historically difficult waterways to build under, thanks to a shifting, silt-heavy riverbed that has swallowed lesser engineering attempts for centuries. Here's the mechanism that makes this project genuinely record-setting rather than just another river crossing. The tunnel was constructed using a shield tunnel boring machine, a massive cylindrical rig that grinds through earth while simultaneously assembling the finished tunnel wall directly behind it, cutting a bore now confirmed as the largest diameter underwater shield tunnel completed anywhere on the planet. Think about what that superlative actually means. This isn't the longest tunnel or the deepest tunnel, it's the widest one ever successfully driven underneath a body of water. A completely different and, in some ways, more dangerous engineering problem, since a wider cutting face means a dramatically larger surface area constantly fighting against water pressure and unstable soil at every single meter of progress. Here's what the project is actually for. Connecting the urban area on the river's south side directly to a new state-level pilot zone built for free trade, innovation, and economic reform on the north side, specifically designed to physically stitch together two halves of a rapidly growing city that had previously been separated by one of the most difficult rivers in the country to cross underground. The tunnel was slated for completion around late 2025, officially confirmed in engineering trade coverage tracking the build. But as record-setting as the widest underwater tunnel on Earth sounds, the next entry on this list isn't just one tunnel, it's an entire interconnected system that set 10 separate world records at once. Number 5 is the Shenzhen-Zhongshan Link, a mega cross-sea passage that opened to traffic in 2024, consisting of one underwater tunnel, 2 full-length bridges, and 2 artificial islands built specifically to connect them, and it earns its place above the Jinan Tunnel because of the sheer number of firsts packed into a single connected system. Here's the backstory. The project took 7 full years to go from blueprint to opening day, engineered specifically to cut travel time across one of the busiest stretches of water in China's Greater Bay Area, the economic region tying together Hong Kong, Macau, Shenzhen, and a cluster of mainland manufacturing hubs. Here's the mechanism that makes the tunnel section of this project genuinely groundbreaking. Engineers used what's called a steel shell immersed tube structure, meaning individual massive tunnel sections were built on land, floated out to precise coordinates, and then sunk and joined together on the seabed one after another. A construction process the project's own technology center manager described as irreversible, with zero room for error once each section is lowered into place. Here's the number that shows how seriously that zero error requirement was taken. Engineers used 3D printing technology to build a customized intelligent pouring system specifically for this project. A system that ended up saving 2,500 hours of machinery time that would otherwise have gone toward manually pouring concrete into these massive underwater sections. Read that again. Engineers 3D printed a construction system specifically to make sinking city block-sized tunnel segments to the bottom of the ocean more precise. Here's the scale of what this single project actually produced. Over the 7 years of construction, project teams generated more than 170 separate patents and achieved 8 major technological breakthroughs, including entirely new rapid island formation techniques and underwater push-type final joint methods that had never been used at this scale before, contributing to 10 separate world records set across the full Shenzhen-Zhongshan Link project. But a 7-year, 10-record engineering marvel, as impressive as that sounds, is still a smaller and newer project than the crossing that made the entire world start paying attention to Chinese undersea engineering in the first place. Number 4 is the Hong Kong-Zhuhai-Macau Bridge, and specifically its underwater component. And it earns this spot because it's the project that first proved to a skeptical international audience that China could execute undersea engineering at a scale nobody else on Earth had previously attempted. Here's the backstory. The full crossing links Hong Kong to the mainland Chinese city of Zhuhai and the gambling hub of Macau, cutting directly across the waters of the Pearl River estuary, one of the busiest shipping lanes anywhere in the world, meaning engineers had to build underneath active international maritime traffic without disrupting it. Here's the mechanism that makes the underwater section specifically so demanding. Rather than running the entire 55-kilometer crossing as a bridge, engineers dropped down into a 6-point, 7-kilometer underwater tunnel section, precisely where the crossing needed to pass beneath the primary shipping channel, allowing massive container ships to continue passing directly overhead without ever needing to reroute around a bridge pylon. Here's the quote that shows just how difficult this specific stretch was, even for engineers who'd already built the rest of the crossing successfully. The bridge's own project planning manager said on record that constructing this 6-point, 7-kilometer underwater tunnel gave him sleepless nights, a remarkably candid admission from someone in charge of one of the most ambitious infrastructure projects on the planet. Here's the number that puts the entire project's scale in perspective. Officially confirmed reporting shows the full crossing used 420,000 tons of steel, 60 times the amount of steel used to build the entire Eiffels Tower, all consumed by a single infrastructure project designed to last, according to officials, for 120 years of continuous use. Think about that comparison for a second. An entire structure built using 60 Eiffel Towers worth of raw steel with a design lifespan longer than most of the people watching this video will be alive to see. But even a landmark project, engineered to last 12 decades, is still, fundamentally, a fixed connection built for cars and trucks. The next entry on this list had to solve an entirely different problem, keeping a bullet train moving at full speed while diving underneath one of the largest rivers on the planet. Before this list climbs any higher, it's worth pulling back, because none of these individual crossings exist in isolation. They're all pieces of a single enormous national infrastructure push. China's newest economic blueprint, the 15th Five-Year Plan covering 2026 through 2030, explicitly names major underwater and underground rail crossings among its flagship infrastructure priorities, with a single high-speed rail line connecting Shanghai and Chengdu alone, carrying a total investment of 500 billion yuan, converting to roughly $72.8 billion, comparable to the entire annual gross domestic product of a mid-sized country, committed to just one rail corridor's construction budget. Here's the thing that makes that number land differently once you sit with it. That single project is only one line among a much larger web of similar underseas and underriver crossings currently active across the country simultaneously, each one independently setting new depth, diameter, or length records, which only happens when an entire national engineering workforce, tunnel boring machine operators, marine geologists, structural engineers, has been mobilized at the same time toward the same broad category of problem. This is not a handful of showcase projects built for prestige. This is a deliberate SUS, the same kind of playbook China has already run in high-speed rail above ground, now tamed national capability building exercise aimed directly at the water and riverbeds beneath it. And once you see the pattern at that scale, the final 2 entries on this list, a tunnel already breaking depth records mid-construction, and a planned undersea crossing that would outmeasure the world's 2 most famous tunnels combined, stop looking like isolated engineering flexes and start looking like exactly what they are, the leading edge of a country that has decided no body of water is too difficult to build underneath. Number 2 is the Pearl River Estuary Tunnel currently being carved out for the Shenzhen-Jiangmen high-speed rail line, and it earns this position because, as of this year, it holds the actual title of deepest underwater high-speed rail tunnel ever constructed, confirmed on record, while the project is still mid-excavation. Here's the backstory. The tunnel is being dug by a Chinese-built tunnel boring machine named Shenjiang-1, working beneath one of the busiest maritime regions in all of southern China, specifically as part of a 116-kilometer rail connection designed to cut travel time between Shenzhen and Jiangmen down to under an hour. Here's the mechanism that makes this project so uniquely dangerous compared to the crossings we've already covered. Engineers building beneath the Pearl River estuary have to simultaneously manage extremely high water pressure, geology that's actively fractured in multiple places, and several distinct underground fault zones running directly through the planned tunnel. Path, any one of which would be treated as a serious engineering hazard on its own, all 3 converging at once along the same excavation route. Here's the number that earned this project its world record. Officially confirmed by China's state broadcaster, excavation reached a depth of 113 meters below the seabed, nearly the height of a 35-story building, buried entirely beneath both the ocean floor and the water sitting on top of it, a depth no other high-speed rail tunnel on the planet has reached. Think about the actual engineering demand hiding inside that number. A deputy equipment manager on the project explained that trains running through this tunnel at 350 kilometers an hour require alignment precision measured in millimeters, because even a tiny deviation at that depth, under that kind of water pressure, can directly threaten both structural safety and passenger conditions anywhere in Chinese infrastructure right now. But even the deepest high-speed rail tunnel on Earth is still ultimately defined by depth rather than sheer scale. The final entry on this list isn't trying to be the deepest tunnel ever built. It's trying to be the longest one that has ever existed anywhere on the planet, period. Number 1 is the planned Bohai Strait Tunnel connecting the port cities of Dalian and Yantai, and it takes the top spot on this list because, once completed, it wouldn't just set one record. It would surpass the combined length of the two most famous underwater tunnels currently in existence anywhere in the world. Here's the backstory. The strait separates Liaoning province in China's northeast from Shandong province, a crossing that currently takes travelers roughly 1,400 kilometers of driving, or around 8 hours by ferry to complete, in a region that Chinese engineers have identified as earthquake-prone, adding a genuinely serious seismic risk layer on top of every other undersea engineering challenge already covered on this list. Here's the mechanism behind the plan. Rather than a single bore, the design calls for 3 separate parallel tunnels running beneath the strait. 2 primary tunnels roughly 10 meters in diameter, each carrying the actual rail traffic, plus a third central tunnel built specifically for maintenance access and emergency evacuation, all positioned at least 30 meters below the seabed to clear the fault zone risk running through the region. Here's the number that puts this project in a category of its own. The completed tunnel is planned to run approximately 123 kilometers in total length, with roughly 90 kilometers of that fully submerged beneath the Bohai Strait itself, a stretch long enough that, once finished, it would exceed the combined length of Japan's Sikan Tunnel and the Channel Tunnel between Britain and France put together, the 2 longest underwater tunnels currently operating anywhere on the planet. Think about what that comparison actually means. This single Chinese crossing is designed to outmeasure the 2 projects that international engineers have used as the gold standard for undersea tunneling for decades, combined into one number and then exceeded. Here's the number that shows the financial weight behind that ambition. The project carries an estimated cost of around $36 billion, officially confirmed by the tunnel expert who has worked on its planning since 2012, with trains designed to carry cars through the crossing at speeds of 220 kilometers an hour, cutting the current 8-hour ferry crossing down to a single 40-minute ride underneath the sea. Here's the honest concession worth ending on, because credibility matters more than a triumphant headline. This project has been in active planning for well over a decade, was originally targeted for completion during an earlier 5-year planning period that has already passed, and a tunnel of this length, crossing an active seismic zone, still faces genuinely serious engineering and financing hurdles before a single meter of it is actually dug. That is exactly why it's here at number 1. It isn't just the longest tunnel plan on this entire list. It's the clearest signal yet of how far China is willing to push the very definition of what an underwater tunnel can be. So here's the full picture, start to finish. The Jinan-Huanggang Tunnel already holds the world record for the widest underwater shield tunnel ever completed. The Shenzhen-Zhongshan link stitched together an entire cross-sea system and walked away with 10 separate world records in the process. The Hong Kong-Zhuhai-Macau Bridge proved Chinese engineers could execute at a scale that gave even their own project managers sleepless nights, using 60 Eiffel Towers worth of steel along the way. The Pearl River Estuary Crossing is currently setting the actual depth record for underwater high-speed rail while it's still being dug. And the planned Bohai Strait Tunnel, if it's ever completed, would outmeasure the 2 most legendary undersea tunnels on the planet combined. What you're actually watching across this entire list is the same shift that happened to global shipbuilding a generation ago. An entire category of extreme engineering that Western nations had quietly assumed they'd continue to lead by default, methodically reclaimed by a country that decided depth records, diameter records, and length records were all worth chasing simultaneously, on purpose, at national scale. These aren't vanity projects built to impress tourists. They're the visible proof of an entire engineering workforce that has decided no coastline, riverbed, or sea strait is too dangerous to build directly underneath. If breakdowns like this, the real engineering and the real numbers behind China's biggest infrastructure pushes, are useful to you, hit like and subscribe, because there's more of this coming, including a closer look at what happens the first time a high-speed train actually crosses the completed tunnel beneath the Yangtze River. So here's the honest question for the comments. Does infrastructure ambition on this scale genuinely impress you? Or does a $36 billion tunnel through an earthquake zone sound like the kind of project that should worry you instead? I read every single one.